Okay, so this is a place value system, and we're going to start to talk about decimals. Here are our learning targets. I can name decimal place values to the thousandths. I can draw a number line to represent decimals in the tenths, hundredths, and thousandths. I can compare decimals to the thousandths, and I can understand that moving to the left in place value increases value by 10, and moving right in place value decreases value by 10. Decimals, why do we have them? That's a great question. So let me give you some examples. One reason we have decimals, or one way that we have used decimals often, is in money. If you see here, a penny is 1 cent, and that's 1/100th of a dollar. Nickels are 5 cents, that's 5/100ths of a dollar. Dimes are 10 cents, they are 1/10th of a dollar, or we could also say 10/100ths. And quarters are 25 cents, or 25/100ths of a dollar. We also have used decimals a lot in sports like running for timing and getting accurate times to finish races. We also use them in events like swimming, again, to get times in races to see which swimmer wins in a race. We use decimals in measurements. And my favorite, baseball. We use decimals in baseball all the time for calculating statistics. But decimals are used all over the place. We use them all the time, even you might not even realize it. So let's talk about our place value system again. Here we have the units, or the ones, with ones, tens, and hundreds. Then we move into the thousands period with the thousands, 10,000s, and 100,000s. Then the millions, millions, 10 millions, 100 millions. But it can even go further. I've told you this. It even goes to the billions. So there's the billions out here. And it even goes further. It goes on forever. But the next would be the trillions, and then the quadrillions. But it also goes this direction over here, to the right. So let's talk about what that means. So there's a place value here, and I put in this little black dot. That's called a decimal point. And that just signals that we're not talking about whole amounts anymore. We have to show, if we were writing the number out here, we'd have to show something to show that we're not talking about ones anymore. So the decimal shows that we're talking about something smaller than 1. And the first place value is the tenths. I need you to remember that. So remember, just to the right of ones is the tenths. And it sounds like we're getting bigger again, but we're not. We're actually getting smaller. This is not tens, it's tenths with a TH. So how much is a tenth? Let's talk about that. So this should look familiar. It's a hundreds grid, or there's 100 small little cubes here to make this, and that represents 100. So I'm starting off bigger, and I want to work our way down smaller. So if we divide this or cut this into 10 equal sections, I made some lines here. I know they aren't straight. I did my best. Forgive me. But there are 10 sections, and each one of these has 10 little squares. So I divided this 100 into 10 pieces. So each section is 10. And it would look like this if I cut one off. Now we have a 10, right? So we started in 100, and now we're down to a 10. And we're moving our way to the right in the place value system. So that's our 10. And if I took that and I cut that into 10 equal pieces and took one of them, it would look like that. And here's our ones. We went from 100 to 10 to 1. Now, decimals are even smaller than this. So I had to make this big. It didn't change. I just made it bigger so we could see this. So we take this and we cut this into 10 equal pieces. And so there are 10 equal sections, or best I could, I drew it with my finger here on my computer screen. But there are 10 sections, and each section is a tenth. So this is one whole thing. But if I take just a sliver of it, just a tenth, 1 out of 10 pieces, that's what a tenth is. And a tenth is written as 0.1 in decimal form, and we'll talk more about that. Here's another example of how we use tenths and how much it is. If you open the timer on your iPad, if you want to just pause right now, just listen to me for a second. Pause the video, open your timer, and start to the stopwatch, and just watch this number right here. And this one, this is the hundredths. We'll talk about this in a second, but just watch how fast tenths are. That's a tenth of a second, so it has to go start at 0 and go all the way to 9 before 1 second occurs. And you know how fast seconds are, right? So tenths of seconds are super fast, and hundredths of seconds are almost so fast we can't even see it. So how much is a tenth? It literally is anything you can partition or cut up or divide up into 10 equal pieces. One of those 10 pieces is a tenth. So these are tenths of a dollar, right? We don't cut up dollar bills into 10 pieces. In fact, that's illegal, so don't do it. But if we did, that would be a tenth of a dollar right there, because that's 10 pieces, and this is 1. We actually call those dimes, so we don't have to cut them up, right? We already have that. We just get dimes. But you can cut up pi into tenths, right? This is a tenth of the pi right here. That's a tenth of 1 pi. And I put 2 together, and that's 2 tenths of a pi, and 3 tenths of a pi, and so on. That's what we're talking about. Anything you can cut up. We could take 10 dots and divide it into 10. And so this one right here would be a tenth of the 10 dots. We could do it in groups of 100. This is 100 dots, and I divided them into 10 equal pieces. So this is a tenth of 100 dots. So what makes a tenth? If you can split it up into 10 equal pieces, those are tenths. That's how it works. So if there's anything that you can split up into 10 equal pieces, those are tenths. So here we are back at our place value system. We know millions. And man, I'm going to try and get you to understand how big a million is. It is huge. Then there's thousands. And then there's these, which really this is kind of the extent of what I can represent on my computer screen. Once we get to thousands, it's getting too big. I can't show you on my computer screen. Millions, forget about it. There's no way. So hundreds, tens, ones, tenths. I'm going to try and show you hundredths, which is next. And that's even getting pretty challenging, but I'm going to try. So here we are with 1 cube, right? Let me go back. So this would be 1, 1. That's what we're talking about here, 1 cube. But then if I cut it into 10 pieces like I did, and I drew little lines to kind of show you that it's cut up, then we're talking about tenths. Each one of those little pieces is a tenth. Now let's talk about hundredths. Yeah, look how small those are. If I cut them this way, each one of these little things is a hundredth. That would be a hundredth, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's difficult to even see because it's hard to, they're so small, right? But this is kind of what it would look like. This little tiny corner, I don't know if you can see that, that little tiny dot on this ones cube is a hundredth of it. So the next thing I need you to understand is that as we move to the right, we are getting 10 times smaller. It's 10 times smaller. I moved the 1 here, that's 10 times smaller, and 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 smaller, and smaller. There we're at the 100 level, and that's what this looks like. That's a 1/100 piece. And then 10 times smaller, so that's a 10. And 10 times smaller, and so we're here, the 1. And then 10 times smaller, and we're at the tenths. And then the hundredths. And notice I have to put a 0 there. That's a placeholder, right? If I just wrote a 1 with a decimal next to it, it wouldn't make sense. We wouldn't know that it's a hundredth without the 1 or the 0 in between there. And then we start going back, and this moving the 1 from here to here made it 10 times larger, and 10 times larger, and 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 it would keep going if I had room into the billions and trillions. So this is how our place value system works. When we move to the left, we're getting 10 times larger each time. When we move to the right, we're getting 10 times smaller each time. Okay, that's all for now.